All right. Given two vectors, vector A and vector B, okay, in unit vector form ijk. Calculate the value of the dot product between A and B. All right. So how to find the dot product? All right. So okay, like that. So for the first questions, A dot B, okay, is this 3i, okay, plus 2j minus 4k dot with negative 5i plus 8j minus 2k. Okay, we know that when we know the basic principle, I dot I, you get 1, isn't it? I dot I equal to 1, but when I dot j, you get 0. Similarly, I dot k, you get 0 also. You get 0 also. Yeah, you can look back to the notes. Okay, why is it this one equal to 1, this one equal to 0? Yeah. So what I can say is when we carrying out a dot product actually is a multiplication of vectors. So when you want to multiply these two together, it's the same as you try to expand it. Yeah, it's like the I, this thing multiply 3i multiply with 5 negative 5i, the 3i also multiply with 8j, and 3i also multiply with the negative 2k. But the thing is, when the I multiply with I, you get value 1. But when I multiply with j or I multiply with k, you get 0. You understand? You understand that? That's why we look for pairs. That means we know that 3i multiplied with negative 5i, you will get something. Okay? But if you multiply 3i with 8j or 3i multiplied with negative 2k, you get nothing, because all will be multiplied by 0 and you get nothing. Okay, same thing goes to this 2j multiplied with negative 5i, you get nothing. But if j multiplied with j, you get something. Okay, so actually we multiply all of them. Okay, so in the end, we look for pairs. 3i, okay, I just use a highlighter. Okay, 3i I multiply with negative 5i, we will surely get something. And then the other pairs is j multiplied with j, you get something also, you get a value. And then the k multiplied with k, you also get a value. Okay, you certainly get a value. Okay, because we know that we know this thing, I multiply with I, you get 1. Same thing goes to j multiply with j, and then also k multiply with k. They will get equal to 1. Yeah. So we take the I multiply with I, j multiply with j, and k multiply with k. So what happened is, okay, we know that I multiply I, you get equal to 1. So the I and I disappear. What left is only the constant in front, which is 3 multiply negative 5. Okay? The I multiply I become 1 already, so we no need to write. Okay? The next thing is 2j multiply with 8j. The j multiply with j get equal to 1. So disappear, left with only the constant 2 multiply 8. So plus 2 multiply 8. And then the k multiplied with k disappear. What left is only the k multiplied k, we get 1. And so what's left is the constant, -4 multiply -2. So plus -4 multiply -2. So what's the answer? Let's calculate. So I got the answer equal to 9. Okay? Easily done. Okay? Always just multiply with the pairs. Okay, so I already got the dot product between A and B. So how about question 2? Question 2, actually, if you look at the syllabus, we just need to state the formula of dot product. So this actually question 2 is out of syllabus, but we still can do this question. Let me show you how. Yeah, what's the formula for dot product? Yeah, let us understand more about this formula, the dot product. A dot B is equal to the magnitude of A multiplied by the magnitude of B cos theta. For dot product, you use cos theta, but for cross product, you use sin theta. One thing to note. So you must understand each part of this. Okay, each part of this. From the we can find the value angle theta between these two vectors. From here, this is the theta we need to find. Okay, so we already got A dot B, which is equal to 9. Okay, it is a scalar. You see, can you notice? This is a dot product. This is a dot product, and that's why here you get a scalar product, because it is a scalar quantity. 9 is a scalar quantity, has no direction. Multiply these two vectors together using a dot product, you get a scalar quantity. That's why we call dot product is also a scalar product. Okay, so now A dot B we got 9. Okay, A dot B we got 9. So now next is we need to find the magnitude of A. So the magnitude of A, okay, let us find out the magnitude of A. Okay, so the vector A is 3i, 2j, -4k. So the magnitude is, we use the Pythagoras theorem for all three constant. Yeah. So that means the 3 we square, and then the 2 also we square, and then the last thing is the -4 we also square, and then we square root everything. That is the Pythagoras theorem. Okay, so what's the answer? Okay, calculator shows the value of square root 29. Just maintain as the third form, so more accurate. Don't use the decimal form, because less accurate. Okay, so how about the magnitude of B? Magnitude of B is, okay, let's look at the vector B. Vector B is -5i plus 8j minus 2k. So we Pythagoras theorem again. Okay, Pythagoras theorem. So this is a -5i square, and then the 8 also square, and then the -2 we square it. So square root, and the answer we get is, okay, so the answer we get is square root 93. Okay, so that's our magnitude of A and B. Magnitude of A multiply with magnitude of B, and cos theta. From here we can find our angle theta. All right, so let's solve it. Okay, so the calculator shows that cos phi is equal to 0.1733. Okay, but this is not the answer yet because this is only the cos theta. So we need to anti-cos, anti-cosine. So let's press the anti-cosine. And okay, remember to change your calculator into degree, not radian. Yeah. Remember to change to degree. Yeah, don't look at the symbol there. It is degree, not radian. Yeah, your calculator must be in degree. If you get radian, then it's wrong. So in degree, okay, now I anti-cosine. Okay, anti-cosine, and you get the degree 80.02 degree. That's the answer. Okay, is this correct? Yes, it is correct. Okay, the answer theta between the two vectors is 80 degree. Okay, so it's very simple. So the dot product equal to magnitude of A multiplied with magnitude of B using the Pythagoras theorem, and then we can find the angle theta between them. Okay, hope you enjoy. See you in the next videos.